Hello, greetings to everyone watching. I hope you are doing well. I want to thank you all for the massive subscriptions that I've gotten from you. Thank you very much. So today we are going to do various questions, and that is questions on both integration and differentiation. So I have a textbook which I'll be doing random questions. I think probably 3 questions. Then that one will be the end of this video. But all in all, I want to say thank you very much. And kindly, if you are new to the channel, please subscribe. Thank you. Now, our subtopic today, just like I've said, we'll be doing more of questions. So we shall be doing questions on both integration and differentiation. If you may come across any question that is a problem to you, feel free to ask. I will always be available to help. Now, I'll use a textbook and I'll be doing different questions. So the first question reads, you just listen, maybe you'll pause the video as you write the whole question, but just listen. Question number 1. The acceleration a meters per square, the acceleration a okay, let us leave that one. Yeah, sorry. I have now the question. Sorry. I was just thinking of a question, but I'm sorry. Now, the acceleration a meters per square of an object that starts moving from rest at time t seconds is given by a equals to 2t minus 6. If the initial velocity is 15 meters per second, give an expression for the object velocity. Give an expression for the object velocity. That is part A. Part B, find the velocity at t, that is time, equals to 3 seconds. Part C, give an expression in terms of t for the object's displacement. Part D, determine its total displacement in the second and third seconds. And part E, find the maximum velocity that the object attained. Now, let me repeat the first question. The acceleration a meters per square of an object that starts moving from rest at time t second is given by a, that is acceleration, equals to 2t minus 6. 2t minus 6. If the initial velocity is 15 meters per second, give an expression for the object velocity. Remember, in the previous videos, I told you something, that before you do any question involving integration or maybe differentiation, make sure you write the formulas first, because that is the only way you will be able to do these questions. Now, the formula is there to help you memorize and also to make you know what you are doing. Are you Differentiating or are you integrating? Now, the formula I told you was the SIVA, the SVA, the SIVA. So, when you're going up, you integrate. You integrate. When you're coming down, you differentiate. You differentiate. Now, the formula remains. When you are integrating, y equals to x n plus 1 all over n plus 1 and plus c. And c there stands for constant. Now, when you are differentiating, we have dy over dx, that is Naxnia. That is nax power n minus 1. Now, the question asks, part of the question request us that give an expression for the object velocity. What have we been given? An examiner has given us acceleration, and that acceleration is 2t minus 6. And what does the examiner want us to get? Examiner wants us to give an expression for velocity. And remember, coming back to our formula, we have acceleration, then the examiner now wants us to get velocity. That means we are going up, and so we are integrating. And you have the formula with you. Now, that question, it has some words which you must not ignore. The word initial. I remember telling you that when you see the word initial, time is 0. That one was covered under the previous video, that is under VVV. Very, very, very important terms. Now, the initial is there. That means that time is 0. For the initial to be there, that means there is something that we must get. There is something that we must get. Now, when we are integrating, so if we integrate acceleration, we shall get velocity. When we integrate acceleration, we shall get velocity. Okay, but before doing that, okay, let us first integrate. That means velocity. Remember, we are integrating. Y equal to x n plus 1 over n plus 1 plus c. That is the constant. So that means this is what we have, and it is the acceleration. It is what we are integrating now. That means velocity will be equal to what? There is invisible 1 at this. There is invisible raised power 1. So it is we now add. That is now it will be t squared minus what? Minus 60 plus the constant. If you are not understanding, feel free to drop a comment. I will be able to do a video and explain to you in a way that you will understand. Please. Now, we have the velocity there. V equals to t squared minus 60 plus c. That one is after integrating. This is what we get. Now remember, the initial velocity has been given, and that initial velocity is 15. And that word itself, initial, symbolizes something, that time is 0. Now, equate or substitute. So that means velocity, which is 15, equals to, remember initial has appeared there. That means that time, whatever the t that is there, is 0. So 0 squared minus 6 into 0 plus c. That means our constant will be 15. So the expression, the right expression for this velocity will be what? V equals to, come to this expression, remember the main reason why we are adding c is to get the full expression. So now we are having v equals to t squared minus 60 plus the constant, which is 15. Now you don't write plus c because plus c is just a formula directing. That is part A. Part B. Find the velocity at t equals to 3 seconds. Find velocity when time equals to 3 seconds. Very much easy. You just substitute v equals to where there is t, substitute with 3. So we are having 3 squared minus 6 into 3 plus what, guys? Plus the constant, which is 15. Press this in your calculator. Your answer will be 6 meters per second. 6 meters per second. And that one is our answer. Part C. Give an expression in terms of t. Give an expression in terms of t for the object displacement. That means the examiner wants us to get the displacement. And the displacement is always a symbol of S. Remember, there are these two symbols. We have the long S and we have the small s. The long S is for integrating. The small s symbolizes displacement. So do not get confused there. Now, give an expression in terms of t for the object displacement. That means an examiner wants us to get the distance. So that means we are moving up. And when we are moving up, we are what? We are integrating. Now, what are we integrating? We are integrating velocity to get displacement s. We are integrating velocity to get displacement s. So that means displacement will be what? Remember, this one is displacement, not integrating. This symbol I've written here. This is displacement. Now, we are integrating velocity. And remember, we are using this expression for velocity. So what will you have there? We have 2 plus 1, that is 3. Over the denominator, that is a third t cube, minus coming here, there is invisible 1, that is 1 plus 1, that will be 6 times 2, that one will be 1 plus 1 all over 2, denominator 2, then plus 15, we are having the constant t. So what will be our displacement? The displacement will be now a third. That is 1 over 3 t cube minus 3 t squared. Remember, that one is after simplification. Remember, we are having 1 plus 1 all over the same 1 plus 1, which is 2 over denominator here. So this one cancel this, and we are having now 3t squared. So that is where the 3t squared is coming from. Now plus 15 what? 15t. Remember, you are integrating. Do not forget what the formula is directing. That is addition of c, addition of constant. And this is what an examiner requires. And that is the answer. Part D. Determine its total displacement in the second and third seconds. These questions are always very much confusing. Determine its displacement in the second and the third seconds. Now, there are 2 ways of solving this question, but avoid there are 2 methods. There are two methods of which one can get the displacement. Remember, whatever an examiner requires in this part is the actual distance, the real distance, but not expression, but the actual or the real distance. Now, we have the second and the third second. That is that is S2 and S1. S2 and S1. The second and the third seconds. I don't know if you guys are understanding. Okay. So whatever we are doing is this. We have second S2 and the third S3. Whenever you see S2, S3, don't forget there is a starting point. There's a starting point. For you to be number 2, there is number 1. For you to be number 3, there is number 1. And for you to be number 1, you are the leader. There is no any other person ahead of you. You are the first. You are in the front position. So whenever you see S2, S3, do not forget that there is S1. There is S1 at the very first. So whatever we'll be integrating is this. We'll be having S1, S2, and S3. From the question itself, determine its total displacement in the second and the third second. There's some things that I first want you to know. I'll explain them later and also give you a formula on how you can do this question in a simplified way. So just for now, just stick with me, just be with me. Okay. Now, remember this S1, S2, and S3. They are just time. They are time expressed in seconds, but an examiner is not telling you exactly that one is time. An examiner is not telling you directly that whatever Yossi has provided is time, but you have to know, you have to reason that the second and the third seconds, those are time. Now, we have to integrate because that's the only thing we are doing. And remember, already we have an expression. Already we have an expression for the distance. That is part C, which we've already done. This one here. So that means S, which is displacement, equals to what? A third what? A third T cubed. A third T cubed minus 3T squared minus 3T squared plus 15T plus 15T plus 15T. Now remember, at this part D, you must ignore the constant sign at first. You will have to ignore the constant part because you can't get it. At this point, you can't get the constant C. You can't get it because there's no further explanation for getting it. There's no initial, there's no any other provided information. So that means the expression one will use is only this one. This is the only expression you will use in that second part because plus C will not help you anywhere. So remember we have S1, that is second one, the first second. So let's start with that one. Let's start with the S1. Now we are substituting a third into the first time, the first second, that is 1 cubed minus 3 into 1 squared plus 15 into 1 remember, when we are doing this, we are integrating step by step, and I will tell you that method. So remember, you are having these notes somewhere with you that I will later give you the clue in the last videos that we will be making of in this question. So make sure you are having these videos with you, this question with you. Just note them somewhere in a neat book. So whatever I'm doing in this part, I am integrating. I am integrating from 1 to 2. And what am I integrating? I'm trying to integrate the velocity, which already had already done to get what? To get S. And that S is a third t cube minus 3t squared plus 15t alone plus 15t. And now these ones, these are time. These are time. So these are what I'm substituting. Remember, I'm in the second part. I've not read the third. Remember, this thing is like a sequence. It's like a sequence. Okay. Let me remove this. Let me wrap this. So we have S1. Having this in my calculator, step by step, I'll be having 12 and a third. 12 and a third. And remember, this is the displacement. This one is displacement. And at the first, the acceleration was given in meters per second square. That was the acceleration. That means that the displacement will be in meters. Displacement will be in meters. Now, that one is the first displacement. The second displacement, which is S2. The two I'm writing at this point, that one is time. That one is time. So I'll have what? I'll have now a third into 2 cubed minus 3 into 2 squared plus 15 into 2 plus 15 into 2. Having this in my calculator, I will get a 20 and 2/3 meters. 20 and 2/3 meters. Remember, this is the first part. This is the first part of displacement. This is the first part of displacement. The second part is ranging from 2 to 3. Ranging from 2. We are integrating velocity ranging from 2 to 3 to get whatever we have already obtained. That one is S. Which was what? Which was a third t cube, minus 3t squared plus 15t. So we are now having that. So we are having S2. Now S2 will be a third. Remember, this thing flows like a sequence. It is like a series. It follows a pattern. So we are having a third into 2 cubed minus 3 into 2 squared plus 15 into 2, which already we have the answer. So this one will be 20 and 2 all over 3 meters. 20 and 2 all over 3 meters. Remember, this part normally contains 4 to 5 marks. So you must be very keen. Now S3, we are having a third into now 3 cubed minus 3 into 3 squared plus 15 into 3. Now, what will this one give us? The work of a calculator. That one is 27 meters. Now, we are adding this. we are adding these to get the total displacement in the second and the third second. And remember, in that between, there is the first second which the examiner is not telling you about. So we are having now S1 to S2. Sorry. We are having S1 to S2, that is velocity integrated plus what? That in 2 to 3. Velocity integrated from 2 to 3. So the total of these, remember integrating V to 2, we had the answer. And this other part. So it is just a matter of adding. But before you add, remember when you are integrating from this end, from the bottom to end, you must get the difference of 2 and 1. You must get the difference of 2 and 1. Now, at this very first integrated velocity, that is 1 to 2, we had what? So at S1, we had 12 and a third. At S2, we have 20 and 2 over 3. So we are getting the difference, the difference of 20 and a third and 12 and 2 and 12 and a third and 20 and 2 thirds. So we are having what? We are having 20 and 2 thirds. 20 and 2 thirds minus 12 and a third. That is for the first part of integration of this velocity. That is the first part. So the difference of this, we are having 8 and a third meters. The same we do to the second part of integrating velocity from 2 to 3. We are getting the difference, and that is the difference. Remember S3, we had 27. S3, we had 27. And S2, we had 20 and 2 thirds. Now, get the difference. That one is now 27 minus 20 and 2 thirds. Doing this, we are having 6 and a third meters. So that means that the total displacement will be what? 8 and a third meters added to this other one, which is 6 and a third meters. So the total displacement will be what? The total displacement will be 14 and 2 all over 3 meters. 14, 2 all over 3 meters. Part E of the question. Find the maximum velocity. That the object attained. Find the maximum velocity that the object attained. Remember, these are secrets that I had already given you. The maximum, the minimum, when you see them, what do they represent? What do they stand for? Equate acceleration to 0. Equate acceleration to 0. Now, that part E, acceleration equals to 0. When you see maximum velocity or minimum velocity. So acceleration equals to 0, which equals to what? Remember our acceleration at the first part of the question, that is part A. We had our acceleration to be 2t minus 6. 2t minus 6. So that means 2t minus 6 equals to 0. 2t equals to 6. Divide by 2, divide by 2. T equals to what, guys? 3. They want maximum velocity. The expression for our velocity, remember at that first part, that's very first part of the question, we got it to be 2t squared minus 60 plus 15. So to get the maximum velocity, where there's t, substitute with 3. So we are having 3 squared minus 6 into 3 plus 15. The work of a calculator. This one gives us 6 meters per second. 6 meters per second. That is the first question. Let us look at question number 2. After t seconds, a particle moving along a straight line has a velocity v meters per second and an acceleration of 5 minus 2t meters per second squared. The particle's initial velocity is 2 meters per second. Express velocity in terms of t. Let me repeat the question. After t seconds, a particle moving along a straight line has a velocity of v meters per second and an acceleration of, this is the acceleration, 5 minus 2t in bracket meters per second square. The particle's initial velocity is 2 meters per second. Express v in terms of t. Remember to write the formula. That is part A. Before we do that, part A, part B. This is Roman 1. Roman 2. Determine the velocity of the particle at the beginning of the 3rd second. These are terms that you should start noting them down, because there is something I'll tell you. Determine the velocity of the particle at the beginning of the 3rd second. These words are very, very much crucial in this topic. And part B, find the time taken by the particle to attain maximum velocity and the distance it covered to attain the maximum velocity. Part B is a 2-in-1 question. Now, let us start with the first one, part A, Roman 1. Express v in terms of t. Remember to write the formula. That one is SVA. When you are going up, you integrate. Coming down, you differentiate. SVA. Now, just to repeat the question, after t second, a particle moving along a straight line has a velocity of v meters per second and an acceleration of that 5 minus 2t meters per second square. The particle's initial velocity is 2 meters per second. So, what has an examiner given us? An examiner has given us the acceleration. That is 5 minus 2t meters per second square. Remember, do not forget to write the formula. I am forgetting to write the formula. When you are integrating y equal to x n plus 1 all over n plus 1 plus c. Just sit down and master this formula. When you are differentiating, the dy over the x is equal to nax near. The y over the x equals to nax near nx n power n minus 1. Okay, what has the examiner given us acceleration. And what does examiner want us to get? Velocity. Examiner want us to get velocity. Now, we are moving up. That means we are integrating. So we are integrating acceleration to get velocity. We are integrating acceleration to get velocity. So that means velocity will be what? From this and from the formula itself, that one will be 5t minus what, guys? Minus t squared plus c. But remember, the initial velocity has been given to be what? To be 2. And the word initial has been included there. That means that our time is 0. So 5 into time, which is 0, minus 0 squared plus c, which is the constant. So in short, we are getting the constant. So the constant will be 2. So that means the right expression for the velocity, or the correct answer for the velocity in terms of expression, will be 5t minus t squared plus 2. So we are having this, and that is the answer. Roman number 2. Determine the velocity of the particle at the beginning of the 3rd second. The 3rd second at the beginning. That means our time is 2 seconds. At the beginning of the 3rd second. That means our time is 2 seconds. At the beginning of the 4th second, the time fully covered there is 3. At the beginning of the 5th second, the time fully covered there is 4. So make sure you read and understand the question. Now, this is just a matter of substituting. So we have 5 into that is time, which is 2, plus 2 squared plus 2. Work of a calculator, the answer there will be 8 meters per second. Part B. Find the time taken by the particle to attain maximum velocity and the distance it covered to attain maximum velocity. What distance did it cover to attain that same maximum velocity? Remember, at maximum velocity or minimum velocity, acceleration equals to 0. So acceleration equals to 0, which equals to, what was our initial acceleration? The acceleration that was provided in the question. That one was 5 minus 2t. So that means 5 minus 2t equals to 0. So we are having 5 equals to 2t divided by 2. That means our time there will be 2.5 seconds. Okay, that is the first question answered. So that means the particle will take 2.5 seconds to attain the maximum velocity. That's 2.5. Let's answer the second part of the question. That is the distance it covered to attain that maximum velocity. Now remember, this distance is required, so we integrate going up. So what are we integrating? We are integrating velocity to get what? Displacement s. So that means displacement s will equal to 2.5. Remember this. This is whatever we are integrating this. This is what we are integrating. So it is what? It is 2.5 t squared Where is 2.5 coming from? Remember this invisible 1 here. So it is 1 plus 1. Then that 1 plus 1, which is 2, it is all over the denominator here. So 2.5 is coming from that arithmetic. So we are having 2.5 t squared, 2.5 t squared minus a third t cube. Where is a third coming from? Where is a third coming from? Remember, it is 2 plus 1 all over 3. And 2 over 3 is the same as a third t cubed. Very much correct. Very much correct. Plus what, guys? Plus 2t. Plus 2t. Where is t coming? Remember, t is a constant at this point. T is constant. T is constant. So don't worry much. After having this, this is the displacement in expression. In terms of expression, this is the displacement. But remember, whatever the examiner requires is the distance, the actual distance in figures, in value. So we substitute. Remember, the time for it to attain maximum velocity is there. That is 2.5 seconds. The same time is required for the particle to attain the maximum velocity for the distance covered. So we only have to substitute the time. So 2.5 into what? Into the time. The time there was 2.5. 2.5 squared minus a third, 2.5 cubed plus 2 into 2.5. The work of a calculator. The work of a calculator. Having this, remember, no matter how long that answer is, write it the way it is. Then after writing it, then you will come to, it is when later you will come to round it off, or maybe to truncate it. Remember, you only do this when the question doesn't specify to how many significant or maybe decimal places should you leave your answer. So after having this, if you don't want your answer in a long format like this, you can approximate your answer. And this is the symbol of approximation. You can approximate your answer maybe to 4 significant figure, and your answer will be 15.42 meters. Remember to include the units when they are provided. Let us look at the last question, then we end our lesson. Let us look at the last question for this. Okay. A particle is moving along a straight line such that its displacement s meters after t second is given by s equals to t plus 3 over 2t squared minus t cubed. Part A of the question, find the displacement of the particle in the first second. Find the displacement of the particle in the first second. Part B, calculate the initial velocity and initial acceleration of the particle. Part C, determine the time when the particle was momentarily at rest. I think I talked about this. Momentarily at rest. Part D, find the displacement of the particle by the time it came to rest momentarily. And part E, calculate the maximum speed attained. Calculate the maximum speed attained. Let me repeat the question as we do it. Now, a particle is moving along a straight line such that its displacement s meters after t second is given by s equals to t plus 3 over t squared minus t cubed. Part A, find the displacement of the particle in the first second. Solution. Remember, do not forget, in any question you are doing, if still you can't master the formula, but even if you master it, I just encourage you to write the question. So we are having the formula S V A. When you are going up, you integrate. When you're coming down, you differentiate. You differentiate. Remember, the formula for integrating y equals to x n plus 1 all over n plus 1 plus c. When you're differentiating the y over the x equals to nax n minus 1. Okay. Now, after doing this, remember, you are writing this at the corner of the question, of that question, of your booklet maybe. So after writing this, now you come back to the question. Find the displacement of the particle. Find the displacement of the particle in the first second. Nothing is difficult there. Remember the what? The expression or the equation for the displacement has already been given. That is t plus 3 all over 2t squared minus t cubed. So we are having this. So that means if you can read and understand the question, the particle, find the displacement of the particle in the first second. So that means the time is 1. So you just substitute. So 1 plus 3 all over 2 into 1 squared minus 1 cubed. The work of a calculator, your answer will be 1.5 meters. Remember, it is displacement that is required at that part. Part B, calculate the initial velocity and the initial acceleration of the particle. 2 in 1. So calculate the initial velocity. Remember, we are initial velocity. What are we having? We are having S. That is the displacement. And what does an examiner want us to get? Velocity. That means we are going down. So if you're going down, we are differentiating. So that means ds over dt equals to what? What are we differentiating? We are differentiating the displacement, and our displacement was what? T plus 3 over 2 t squared minus t cube. And remember the formula for differentiating. dy over dx equals to what? Nax near. So that means, what are we having here? ds over dt equals to velocity, which equals to what? Now, what will be our velocity now? Our velocity will be 1 plus what? Plus what, guys? Plus 3t minus what? Minus 3t squared. If you're not understanding how I'm getting this, feel free to drop a comment. I'm telling you for sure, I'll be able to teach you for free. I'll be able to spare my time for you to understand this. Okay. This is the velocity. And remember, they want initial velocity. So that means the word initial with velocity, time is zero. So v, remember, v has been included with the word initial, and initial time is 0. So we are having 1 plus 3 into 0 minus 3 into 0 squared. So what are we having? After solving this, obviously our answer will be 1 meters per second. 1 meters per second. Now, and remember, this was a 2-in-1 question. So the question continues to ask, and initial acceleration of the particle. we are still going down. We are still going down. That means we are differentiating. We are continuing with the differentiating. So what are we differentiating? We are differentiating velocity in respect with the time, dv over dt, and dv over dt equals to what? We are integrating velocity. So integrating this, remember 1 is nothing. So we are having 3 minus what, guys? Minus, remember 2 comes there, multiplied by that. So we are having 60. So dv over dt equals to 3 minus 60, which equals to what? This one equals to acceleration. This one equals to acceleration. So our acceleration will be 3 minus 60. 3 minus 60. 3 minus 60. Remember, initial acceleration. That one should give you a clue that time is 0. So A equals to 3 minus 6 into 0. Having what? Having 3 meters per second squared. So that is that. Part C of the question. Determine the time when the particle was momentarily at rest. Determine the time when the particle was momentarily at rest. Did I talk about momentarily at rest? Yes, I did. And I said that momentarily at rest, equate velocity to 0. So what is our velocity? The expression for our velocity v, the expression for our velocity v was a 1 plus what, guys? 1 plus 3t. 1 plus 3t minus 3t squared. Observing this is quadratic. And quadratic is always in which format? Ax squared plus bx plus c. So remember, if you see any question in calculus that is a quadratic, remember to arrange it in its format. Of quadratic. So what will we be having now? Negative 3t squared plus 3t plus 1 equals to what? Velocity equals to 0. So equals to 0. Now, you can either use the formulas. There are so many formulas for solving quadratic equation. So I'll use this. Negative b plus or minus the square root of b squared minus 4ac over 2a. Negative b plus or minus the square root of b squared minus 4ac over 2a. Now we are having this. So remember, this is a, this is b, and this is c. A, B, C. So we are having what? Negative 3 plus or minus the square root of b squared. That is 3 squared. 3 squared minus 4 multiplied by a. What is a? A is negative 3 multiplied by c, which is 1, all over 2a, which is 2 multiplied by negative 3. Solving the numerator, we shall have negative 3 plus or minus whatever is in the root. Sign, just use a calculator. So we shall have 4.583. It is not a must that all questions under root sign will always be perfect. No, some will have decimal, some will have decimal. All over 2 multiplied by -3, that one is -6, that one is -6. And remember, this one is okay. So we are having that. Now. All over denominator. So as for the numerator, okay, for the first part of the question, for the first part, we shall have -3 plus 4.583 divided by -6. That one will be the first answer. And the second answer will be -3 minus 4.583 all over -6. This one will be the second answer. So as for the Roman one, just use a calculator. We shall have a positive of 1 point. Is it 1 really? It will be negative. So we shall have a negative what? Negative 0.264, negative 0.264 seconds. And as for Roman 2 or Roman 2, we shall have our answer as a 1.264 seconds. Now, it is upon you to reason. Can time be in negative? Can time move backwards? No, time cannot move backwards. So you reject. You reject or ignore. Reject or ignore the negative time. So our answer will be 1.26. Therefore, our answer will be 1.264 seconds. 264 seconds. Time cannot be negative. Part D. Find the displacement of the particle by the time it came to rest momentarily. Remember the displacement, the expression for the displacement, we have it was 2 plus 3 all over 2 squared minus t cubed. They want the displacement. Remember the time. The time taken for the particle to be at rest is 1.264. That is the very same time we shall use to get the distance covered by the particle by the time it covered the distance when it came at rest. So it is just a matter of substitution. So we shall have 1.264 plus 3 all over 2 into 1.264 squared minus 1.264 cubed. Having this in your calculator, our answer will be 1.64 meters. The last part of the question, calculate the maximum speed attained. Maximum. Remember, at maximum, what is 0? Acceleration is 0. So acceleration equals to 0, which equals to what? Already we had already gotten the acceleration. Is it? Okay. Acceleration. Did we get the acceleration really? I don't. Yeah. We have the acceleration. A equal to 3 minus 60. A equal to 3 minus 60. So acceleration 3 minus 60. So let us get time. That is 3 minus 60 equals to 0. 3 equals to 60. So divided by 6, divided by 6, our time is what? It's a half. Time is half. So remember, it is this time that we shall use to get the maximum speed attained. So the expression for our velocity was 1 plus what? 1 plus, what was our velocity? 1 plus 3t. 1 plus 3t minus 3t squared. I hope I'm right. The expression for our velocity. Yeah. This one. 1 plus 3t minus 3t squared. 1 plus 3t minus 3t squared. So what are we having? We are having 1 plus 3. You substitute a half minus 3 into a half squared. The work of a calculator. So having this, we shall have 1.75 meters per second. 1.75 meters per second. This marks the end of that lesson or of this video for today. So when we meet next, we shall tackle the diagrammatic integration and differentiation. That is diagrammatic integration. Diagrammatic integration and differentiation. So when we meet next, this is what we shall be covering. Remember, there are some words I've told you during the revision that you should have taken note of. I will not be able to discuss them in the video of diagrammatic and differentiation, but later I will summarize them when we will be doing more and more of these questions involving calculus. Up to this end, I thank you for watching, and if you have not yet subscribed, please do so. And I thank you all, and I wish all the best for you in your studies. Thank you very much. Please share the video, share the channel for me to get more subscribers. It will be my motivation to reveal to you secrets of passing mathematics. Thank you, and thank you very much.